Hi everyone. We are now going to review the chapter review and self-test problems at the end of the chapter on page 145. So I know you're given the answers, but let's walk through this so you understand why the computations are being done the way they are. So in the first problem, it says assume you deposit $10,000 today. So today is your time zero. Today is present value in an account that pays 6% interest. That 6% interest each year compounds at least once a year each year, and you will leave it there for 5 years. Now you can use your formula where you take 1 plus the interest rate to the number of periods power. And then you would put in your calculator 1.06 caret top to the fifth. And you get what we call a factor. So that number converts to 1.3382. What does that mean? If you put $1 away under those conditions of 6% interest, 5 years, you would have $1.3382. But that's not what you're doing here. You're putting $10,000 away. So multiply that by 10,000. Because we want to know how much will 10,000 grow to. 13,382.26. Now you could use your finance app on your calculator. Your N would be 5. Your I would be 6. Your present value is 10,000. And then you use your arrow keys to go to future value. Alpha solve 13,382.26. So either way, you get the same answer. Remember, we're looking to see how much will it grow to. Now in the second problem, it says, suppose you have just celebrated your 19th birthday. A rich uncle has set up a trust fund for you that will pay you $150,000 when you turn 30. If the interest rate, or what we call relevant discount, on this trust is 9%, how much is it really worth today? How much is your uncle putting away for you today so that you can take out $150,000 in 11 years? So in this case, we want to know what is today's value, present value, given what it's worth in the future, future value. The future value is $150,000. The time period is 11 years, and the interest rate is 9%. Now, using your formula, what we would do is first determine what is 1.09 to the 11th power. Now divide that into 1. 2.5804.26405. And you get 0.3875. So what that is saying is, if you wanted to take $1 out under these future conditions 11 years from now, where the investment was earning 9% interest, how much would you have to put away today? 38.75 cents. Well, we want to know how much would you have to put away today to accrue $150,000. So multiply that result by $150,000 and you get $58,130. Now there are some cents on there, but we just rounded it, and which is fine for these calculations. Be careful and connect. That's why I encourage you to always include your calculations, especially on a test, so that I can see, oh, you just rounded and it marked it wrong because you rounded. So if you take in your finance calculator apps, 1 for finance, 1 for time value of money, N is now 11, interest rate is 9, present value we're going to solve for, so I'm going to arrow down and put my future value in as 150,000. Arrow back to your present value, so your cursor is blinking there. Alpha, enter, $58,130. So the first problem, we wanted to know what will it end up being. This problem, we want to know what do we have to do today to get it to that point. The third problem, now we're looking at how we determine the rate of return. So you've been offered an investment that will double your money in 10 years. What rate of return are you being offered? Check your answer with the rule of 72. We didn't look at that. So you can come up with suppose you invest 1,000. You want to double it to 2,000. So you could use this with any number. You have 1,000, you want it to double to 2,000. So your present value is 1,000. Your future value is 2,000. Okay, now remember, we could use our formula. Future value equals present value times 1 plus your interest rate to the 10th power. So divide the 1,000 into the 2,000. 2 equals 1 plus r to the 10th power. Now, we want to solve for r, so we'll bring the 10 over to the 2 and make it 2 to the 1/10th power. Okay, and we could solve for that. Okay, that's the log of 10. Nope, I'm doing that wrong. Just give me a second. Just give me a second here. I'm just figuring it out on my calculator. Nope, I'm doing something wrong there. I'm going to put you on pause a second. You won't even know I'm gone. Okay. Whoops. Hold on a second. I do apologize for that if you got some feedback there and stuff. So I had a little mind blurb there that I couldn't remember how I did this on my calculator. But if we take in our computation there 1 divided by 10, 0.1. So we want to raise 2 caret top to the 0.1 power. That gives us 1.0718. Now bring the 1 from the other side over, minus 1. So our interest rate would be 7.18%. Okay, the rule of 72 says take the number 72 divided by your number of periods, and that will give you your interest rate. So 72 gives us an approximate interest rate, but it's a great check. So that's when you know your future value, your present value, and your number of periods, what kind of interest rate do you need to double your money. Now, when we know our future value, our present value, and our interest rate, and need to determine how many time periods do we need to leave the money in for, in this case, years. Take a look at 5.4. You've been offered an investment that will pay you 9% per year. If you invest $15,000, how long until you have $30,000? And then how long until you have $45,000? So we know our present value, $15,000. We know our future value, $30,000 in the first computation. If you take 15,000 times 1.09 to the 10th power, that gives you, to the t power, I'm sorry, not the 10th, but the t power, the number of periods, that will give you your future amount. So we just fill in our variables into our equation that we know. Take the 15,000 present value divided into the 30,000 future value, 2. 2 equals 1 plus 09 to the t power. If we solve for t, we will find that this takes 8.08 years. Just give me a... Okay, so remembering how we do this calculation, because we're solving for t. So we're actually going to be doing the inverse of 2, or the log of 2. So take the log of 2 on your calculator, 0.3010 to 99957. And then we're going to take the log of 1.09, which is 0.0374264,979. Divide the second log we just did for the 1.09 into the first log for a log of 2. So 0.30102,99957 divided by 0.0374264,979. I know these calculations are crazy, but it will give you your number of periods, 8.04. The rule of thumb of 72 says, well, take the number 72 divided by your interest rate, and that's about how many years? Now for 45,000, we would take 45,000 divided by the 15,000, which would give us 3. Take the log of 3, and then take the log of 1.09, divide the 0.4771212,547, that was the log of 3, by the 0.0374264,979, the log of 1.09, and you'll get 12.75 years. Now, the rule of 72 works with doubling your money. Okay, so you got to keep that in mind. If you take 72 divided by 9 here, it's 8 years. But we're not doubling our money, we're tripling it here. So that's how we find on our calculator using the formulas these various rates and time periods. Remember, for problem 3 and 4, you could use your app. The finance time value of money solver, your N for problem 5.3 is 10. Interest rate you're solving for. Remember to either put your present value or your future value amount in as a negative using the negative in parentheses on your number pad. So I'm putting negative 1,000 for present value, future value. I'm going to put a 2,000 because I'm doubling it. And I'm going to go back up and solve for I, which will give me 7.18%. So it gets kind of crazy on our calculator when we're using the formula. If you use the app to solve it, it's pretty straightforward, just filling in the variables. Now in 5.4, you know your interest rate is 9. Your present value is, I'm putting in it as a negative 15,000. Oops. And then your future value is at 30,000. I'm going to arrow back up and solve for N, which will give me the 8.04. Okay, so just a little review of these various calculations using the formulas. So if you have any questions, please post them to the discussion board.